Hi there. Today is Friday, March 13th, 1992. I'm Gene Renard Ward. This is an internal tape for Slate Corporation. This is a repeat of a presentation I gave on March 11th at the Boston Computer Society Penn Interest Group in Boston. The topic was the history of pen computing. On this repeat of it, I will be eliminating the material that was talking about electronic ink hardware and electronic ink software, because that's covered in a different tape we did back in August. And the reason we're doing this is partly it might be of interest to other people in the company, and partly there may be some material in here that Slate could use in making its presentations to customers about why our apps are better than other people's apps. Thank you. Okay? Now I'm going to go down to the overhead projector. Okay, this is the topic at the BCS meeting. Notes on the history of pen-based computing. This was arranged by Randy Parker at the BCS meeting. The presentation I have consisted of some notes, which I was speaking to, and a lot of pictures of pen-based computing products. The threads in the talk, things I wanted to focus on, are that there's an extensive history that's relatively unknown, that a lot of the things that are now being presented as new developments in pen-based computing are not as new as you might think. In fact, perhaps a lot less new than you might think. Some of the material I'm skipping over are some shortcomings in the current state of the art. I'll be skipping over that right now. And toward the end, we brought up a discussion with the audience on what some of this might imply to people in the pen computing industry or people considering pen-based applications. Several reasons why this topic and this material might be of interest to people in the pen computing business or looking at pen-based applications. One is that there's a lot more history to pen-based computing under different names than almost anybody's aware of, although this is people starting to get a little bit better informed as the pen industry takes off. Another reason is that these historical developments constitute a broad range of examples you might want to study. People were doing these systems with different ideas behind them from what people have now, a little bit different focus. People who were doing this on a research basis were thinking in terms of man-machine interfaces. That was the term that was popular in the early 1960s. They were doing this as a study just of human functionality or usability of different types of interaction techniques. They were perhaps trying to measure cognitive concerns. Another reason for a lot of the early work on pen-based computing was that it was an easy study problem in pattern recognition. It's a popular thing to assign to grad students to give them a $1,000 digitizer and a little bit of computer time and ask them to recognize characters. Most of these people did not have the focus we have today on graphical user interface development. That is one thing that's different. What you find in these early systems is they dealt with exactly the same issues, came up with some of the same solutions, but they perceived them differently and they understood them differently. Okay. This is the slide for the material I'm going to skip in this recording, which had to do with electronic ink. As I said, that was covered in a separate tape we did last August. Okay. And at the BCS meeting, I highlighted there's some topics we were not discussing. We were not doing product demonstrations. We were not doing demonstrations of specific applications. We did have a short videotape at the end that Dan prepared, which showed some of the electronic ink features by chance using Daytimer, Pen Scheduler, Pen Book, and Pen Apps. I also pointed out to the meeting that there would be a general presentation by Slate at the full BCS meeting in May, and that most of the hardware vendors in this area will have their engineers at the Society for Information Display Conference in Boston in May. Okay. The theme I picked for this historical overview is something I call the Leif-Erikson in 1992 scenario. 1992 was the 500th anniversary of the discovery of America by Christopher Columbus. One thing that came out in the press was that in many ways Christopher Columbus was not the first. Specifically, he wasn't the first. But he just thought he was. And he thought he was discovering something completely different. Something that you've heard a great deal in this industry in the last 2 years is one company or another, one individual or another saying I or we discovered or invented pen-based computing or pen-based applications, or we invented handwriting recognition. This really isn't true. And to give an example of it, here are some early references and early developments in pen-based computing. The oldest patent in the United States that I am aware of for machine recognition of handwritten characters in real time is an electrical mechanical system patented in 1914. I'll have a picture on this in just a minute. The numeric input that was supported on this machine was just part of a larger device for controlling heavy machinery. They did this instead of setting switches or programming relays. This wasn't an isolated incident. There were other patents. There was one in 1938, a machine recognition of handwriting. This was also about the time that people were starting to say they'd have the voice recognition problem solved in a few years. Something else that's worth citing is a book that wasn't about machine recognition, but was a study of the writing of Arabic numerals by a guy named G.G. Neil Wright. The reason I cite this is that when I bring this book out and show it to people who work on pattern recognition, they're stunned by how similar the presentation, the analysis, the definition of the problem is to what they've had to do in pattern recognition for handwritten numerals. Okay, I had promised you some pictures. Here it is. Pattern recognition in 1914. I notice the filing date is actually 1910. This is drawing with a conductive stylus over a set of copper pins and a board. This is just one picture out of the patent. The others refer to the mechanical design of the overall device. This is very similar to what some people are doing now in handwriting recognition under the rubric a zone-based recognition system. Now that we've gotten out of the archaeology, we're into the ancient history of pen-based computing. 1956, the invention of the Renard digitizing tablet. This is the first digitizing tablet. It was invented as part of a handwriting recognition project at Rand Corporation. 1957, this and other projects were written up at the Eastern Joint Computer Conference. It's interesting to note that in 1957, they were stating that they were getting a 97% successful recognition rate, and that this was a much better user interface device, although they referred to a man-machine interface, than a keyboard. The application was filling out coding sheets and editing them in real time for Fortran programs. Something we used to joke about at a company I was working at in the 1970s is that the recognition rate started out at 97%. They're getting better all the time, and they'll exceed 100% any day now. There was also a paper done in 1960 on human perception of hand-printed characters, which showed that humans, on a character-by-character base, only recognize 97% of the characters. The rest they get from context. It's interesting to think what it means to say that you have a machine that's getting better recognition than that. 1962, in the IRE transactions, which is now the IEEE, paper claiming 99.79% recognition. Paper 1962 by J.C.R. Licklider, who worked on ARPANET, online man-computer communication involving electronic ink and online recognition. 1961, 1963, several papers and patents from Bell Labs on real-time, reliable recognition of cursive script. And then one that's very interesting, the Grail system, done in 1964, 1966 at Rand Corporation. This was a user interface application system that included text character recognition, gesture commands, electronic ink, sketch recognition, and printing up handwritten drawings. It's a good time to get to some pictures. This is a system that was done in the mid-60s. A guy named Bernstein. One of the pictures here is a picture of their digitizing tablet, which used sonic transducers down two sides of the tablet. And notice they're talking about this being an event-driven problem, referring to some of the problems of smoothing on electronic ink. Just a moment. Here we have a picture of some of the applications they were doing. I apologize for the copy of this image, but some of these papers are pretty old. It's hard to find them. You'll notice here, in particular, that one of the applications they're demonstrating is inputting algebraic equations, two-dimensional mathematical parsing. This is something that MCC was working on very heavily as recently as a year and a half ago, until their group was disbanded. Here's one picture of the Grail system, 1966. You notice that here they're putting in flowcharts. It's a sketching program. Another picture of the Grail system, talking about the ability to translate the characters to a standard form and referring to the inked version of the symbol. Another one of their papers has the first reference I found to the term electronic ink. Actually, that's on this page right here. This is 1966. Talking about that the user interface works with a single device, namely a pen, not multiple devices, not multiple fingers, both hands, that it's easier to use. One question that we can ask is why this didn't catch on more, and the reason is this is the personal computer they were using. 360 Model 40, which I understand the base price was $500,000. This is in 1964 dollars. There are some changes in the industry since then. Moving right along, we'll get into the early commercial history of pen-based computing. 1973, Applicon Corporation, at that time the leading CAD company in the world, included in their user interface what you would now call a gesture-based command system. This was widely praised. This is considered a much superior feature to the way it was done with other CAD systems. And it was also written up in a standard text on computer graphics, which I'll show you in just a moment. 1974, Xebec Systems, a spin out of SRI, came up with a digitizing pen, no tablet, just a pen. 1976, NEC announced and shipped a commercial product using online handwriting recognition, which is a billing machine. It's basically a computer terminal for taking order and billing information by hand. Get up to 1981, now we find that there are a number of commercial vendors in the area. Standalone units, terminal units, a couple of portable units, companies like Micropad, Image Data, Telepad, Right Away, a number of Japanese vendors. The application areas for these were data capture, data entry, filling in of forms. There's some pictures for you here. Here's the Xebec system. This is a pen with an accelerometer sensor in the cap. Did a reasonably good job on recognizing individual characters, but wasn't so great at telling where you were over the paper, for understandable reasons. Okay. There's another paper from 1970. More work being done at Rand Corporation. There's a picture of their digitizer. You notice the electronics are a little bigger, but the digitizer format was about the same. This could have been used today as a desktop unit. This is the recognizer that was used in the Applicon product. At the time, this was the standard textbook in computer graphics. And this is an appendix in the back. The character recognition was considered a nice little project you assign to students to get a feel for what they can do with graphics hardware.
Could you hold them up a little longer?
Sorry.
Thanks, Dennis. Thanks. Okay. Fine.
Moving on, start to get up into the modern history of pen-based computing. 1982, 1983, PC market came out. You started seeing these products being targeted for personal computers. Some of the companies that were very active then announcing products, most of which are still in business now, were the PenPad product from Pensep Corporation. That's one of the places I worked. CIC announced a very similar product called the Handwriter. Nestor announced a product called the Nestor Writer, again very similar. Applications for these systems were primarily in making handwriting-based front ends to off-the-shelf character-based applications, things like word processing, spreadsheet input. A couple of these companies had handwriting user interfaces to Lotus 123, gesture-based front ends to CAD packages like AutoCAD. Something I want to mention here was a paper that came out in 1983. It was really about voice recognition at IBM. This was a study where they had trained a stenographer to pretend to be a perfect voice recognition system and bring in subjects to tell them that they wanted them to try out a new experimental voice typewriter. The point of the paper was that with absolutely perfect recognition, the subjects found this system very hard to use. It was very hard to use because of mode confusions. They couldn't tell whether they were dictating text or stating commands. The fact that people would stutter, hem and haw, use incomplete sentences, things they didn't like to see coming out of the typewriter. That going back to a particular position on the text in order to edit it, to correct it, was very difficult to do by voice alone. You find exactly these issues in pen-based computing, that even if you had perfect recognition, your system can still be very hard to use, and there's not a lot you can do about it. It's because you're using recognition. 1985, several large companies were starting to write about experimental systems they had in the lab. AEG had several papers on word processing, such as working with WordPerfect, standard off-the-shelf WordPerfect. IBM in 1985 was demonstrating to people who came to their labs a real-time electronic ink gesture-based front end, again to Lotus 123, standard Lotus 123. 1986, company a few more people have heard about, Linus Technologies, announced the second ARM-top pen computer product that I'm aware of. The application here was walking around data capture, something for nurses to use in a hospital for collecting patient information. Half the finance company was from Baxter Medical. 1986, 1987, Mac-based products. The early ones were mostly based around the IBM PC. I'm going to stop right here, come up with some more pictures. This one for you. This is a little note on recognition. This is from a 1963 Russian paper on real-time recognition. Interesting to compare with what some of the people are doing now on character recognition. This is an English translation. Here we have some of the early products. 1981, Telepad, UK company, doing handwritten data entry using a one-line LCD display. Another company from the UK, Image Data. You'll notice that here that they were showing electronic ink on a full display with a digitizer. They were using a desktop system, very thin profile digitizer, with menu areas for applications located down the side. This is a 1982 article. This is from Electronics, a rather large circulation journal, on a system developed in Japan called an automatic draftsman, which would take freehand sketches and turn them into real architectural drawings. Sketch recognition. This is Micropad, another company from the UK. Small unit. Scriptwriter, an American company. This is 1982. This shows a tethered unit, basically a unit that was small but stayed in one place, attached to a terminal. Shortly after that, they came out with a portable unit. I'd like you to remember this picture because we're going to come back to something very similar a little bit later. It's a battery-powered portable unit with handwriting recognition and a small display which could be pre-programmed for any forms and could do automatic calculations on the data in the form. This is 1982, product of the company I was at, the Pen Pad. This was a VT100 compatible terminal, fully compatible using handwriting recognition instead of a keyboard. NEC was active in the market. This is interesting. This is a German company doing Chinese character recognition. Gewerbe Elektronik Berlin. One of the other interesting things about it is their digitizer consisted of a light pen, a barcode reader, not a light pen, running over a barcode pattern on a sheet of paper, very low-cost digitizer. Hitachi, 1982. Handwriting terminals. It's the InfoWrite. We saw this one, the company I was at in 1982 at Comdex. What happened is we announced our product and they announced their product at Comdex. We ran into each other. We were just 2 aisles apart. We hadn't known about each other's existence before the show. In 1983, Pencept announced a PC version of their product, where the electronics are moved to a single card which fit inside the PC on an 8-bit slot. Another product from the UK. You notice the applications areas they list here: payroll, order entry, file amendments, journals, government data collection. All these things are very text-oriented, very forms-oriented. This is the application almost everybody tried for pen-based computing. 1983, you find a lot of the concepts that are now listed under pen centricity, not all of them, but a lot of them, in an article by Ben Schneiderman at the University of Maryland under the heading Direct Manipulation. Another picture of the PC version of the PenPad product. Notice that it's one card. This had a 68,000 microprocessor to do the recognition and the other functions. That product got on the front cover of Byte magazine and was voted Best of 1985 in PC magazine. Still, the company didn't make it. Good press isn't everything. Here's the product from CIC. CIC is an American company, but they were marketing their products in Japan and went to a great deal of trouble to look like a Japanese company in the Japanese market. An example of how some of the companies were doing gesture-based. This is a list of the permitted gestures for AutoCAD Release 3.
Hold it for a second.
I think. This one's from Pencept. Okay. This is something very similar for Lotus 123, which was from CIC. This is 1986. We used to joke at Pencept about how similar CIC's and Nestor's products were to ours, and always about 6 months later.
Is this you would tap on the thing? You would tap on it or directly write it?
You would write here. And you could actually enter a column of figures by just writing down line to line. It would automatically send the codes to move you to the next cell down as you move down and up on the form. Okay. Another Japanese company, some of their literature. Some of AEG's work on doing word processing, the pen. It's from IEEE Micro, not a particularly obscure journal. Picture of the Nestor writer. Several of these products look pretty much the same for text entry. Here's one of the early Mac-based products. Here's paper by Bill Buxton, 1984, on using pen-based input for doing musical notation. You notice something that looks a little bit similar to the concept of a lasso. Similar stuff was being done at IBM. It's not the same as a lasso we have in our products, but the idea of circling something to group it and grab it was already there. Okay. Current events. I think most of us would say that the current generation of pen-based computing started with the grid pad, which came out in 1989. This is probably the unit that sold the greatest volume of shipped units to date. At the conference a couple of weeks ago, Tandy was showing a new pen-based unit, not the original grid pad. It appeared to be the Samsung unit, painted black with the Tandy logo on it. We get into the last year or two, there are so many companies coming into this that it's getting very hard to keep track of them. The application areas are changing a little bit, more emphasis on note-taking. The emphasis is not that this is a portable computer, but this is a highly mobile computer, something that's ambulatory, something you can use while walking around. People dealing more with images, saying it's about the size of a book, I should put things on it that work like a book, things like the PenBook product from Slate Corporation. Something I notice about these, and something we talk about at Slate, is that these involve electronic ink. Data that started written should probably stay written. It shouldn't be ASCII characters. We have some pictures of these current products. I think this audience is probably familiar with them. This is the grid pad. Can you shut the door? Yeah. Means the build finished. You notice Data Entry Systems is now selling the Scriptwriter 2. This is from a year and a half ago. This looks almost exactly like the original Scriptwriter that came out in 1983. You find some pen-based computers in strange places. This is 1989. It's from Flexiterm Company. They didn't think of themselves as doing a pen-based computer, but that's what you have here. You have a digitizing surface, an LCD graphics display on the top, and not overlaid on each other, but the applications they were selling it for involved marking down here and seeing the ink up here. It's a Japanese product. This flyer is from a year and a half ago, although I think this product's just being announced in the US now. A pocket-based pen computer. I think everybody's seen this picture, although I was surprised at the BCS meeting. There were about 10 people who said they had never seen any pictures of pinpoint screens or pinpoint applications. It's also from a year and a half ago. This is some of the Japanese marketing literature on the Refalo. Another system about this time was the Freestyle system from Wang Labs. This one was interesting in several ways. It was both sort of ahead of its time and orthogonal to it. It was completely annotation based. It had essentially no character recognition whatsoever, and was based purely on desktop hardware. You couldn't get this on a portable system. The application that this was used for the most was for real-time electronic messaging, sort of email with handwriting. This is still being sold. Some of the other products coming out now from Sanyo, Eden Group, is licensing their hardware to other people. Samsung, also being private labeled by other people. Momenta, which probably wins on terms of interesting pictures of their equipment. The NEC Ultralight. A couple of people referred to this as a flop top because with the digitizer put into the top of an existing clamshell PC, it tends to flop over when you write on it. And a couple of other things that people may not think of as pen-based computing. This is from the December 1991 issue of Communications of the ACM. This is a paper on a Japanese system for electronic conferencing, essentially with a pen and voice. But there is no recognition. It's purely a communications medium. And just so you get an idea on where the industry might be going, this is a pen-based computer. Sony Sketchman, $119.98. It's already been cloned. It's available here locally in town for about $89.95. And at this point in the BCS meeting, we started talking about hardware and electronic issues. I'm going to skip that and just go to the summary page, where we invited the group to talk a little bit about what this might imply to people in the pen-based industry interested in pen-based applications. Summary was that there is a long history to pen-based computing. There's a lot to learn from it. That throughout a lot of this history, people were trying the same sorts of applications, some of the same ones that people are trying today, and historically they were not successful. The applications that will be successful might be something a little different. And for the applications that are new types of applications, you might characterize them by saying that they're based on note-taking, taking down of handwriting, not of characters, that they're very mobile, and they're in areas where people have not traditionally thought of a computer. One of the people in the audience at this point stood up and made the point that they don't perceive the Daytimer pen scheduler as a computer product. The people they show it to perceive of it as an electronic version of the Daytimer. Much as people who have Nintendo don't think of it as a computer, they think of it as electronic games. That's the end of the talk. Want to do anything else, Dan?
We wanted to talk a little bit about those that are trying to put pens and handwriting recognition over DOS products and how successful that's been in the past.
In the past, it's been a flop, in my experience. There were about 15 or 20 companies working on exactly that approach. One reason was that they were trying to tie into an applications market that they didn't have the resources to develop. And secondly, they perceived that that was where the value was at. It was just in displacing the keyboard away from these existing applications. The techniques that they were using were basically giving you a writing area to replace the keyboard input, and actually doing some fairly clever tricks on being able to track where you're writing in order to position things properly in the application, either for word processing or for a spreadsheet, automatically switching to a mouse mode to when you're trying to move the cursor rather than enter data. I'm not sure that, I think a lot of the techniques that are being developed now in that area are similar to the ones that were done then. Those were not successful. Nobody bought them. Nobody bought them in any volume so that they could make some money.
Any other questions?
Just about every one of those companies also had their own forms-based development package for it. That was what they saw as the application tool that was needed.